surface area. And this right here is the main formula that you need to remember. I'll just go into briefly how this formula comes about. As you recall, so here's the situation. You have a surface. This is part of a surface. This purple thing right here, or this what is it? Purple? Yeah, this is part of a surface, and this is the corresponding projection in the x-y plane. Okay, and the surface is up here, and the surface is determined by z equals f of xy. Okay, so that's the equation for some surface up here. Okay, the area, if this is a parallelogram right here, which maybe it's not, I mean, if it's going to be part of the surface, then it's not going to be, but if you make this small enough, then it's going to be a very good estimate. So this is a parallelogram. Okay, so the area of a parallelogram is equal to, that's formed by two vectors, A and B, is equal to the magnitude of the cross product, right here, the magnitude of the cross product. Now, if you have so this vector here, so if this is a point right here, then this vector pointing in the x direction is, it's not going to be parallel to this one. It's going to be slightly tilted, but the tilt is going to be dependent on, so this right here is delta x right here. So this one also has delta x in the x direction, but in the z direction, it's going to be the partial with respect to x in the z direction, and pointing in along this x here is that partial of this with respect to x times the delta x. Okay, so the a vector is delta x 0 partial of f with respect to x times delta x. Likewise, the b vector, that's going to be 0 delta y partial of f with respect to y delta y. Okay, and so in the cross product of those two is this. Again, the area of the parallelogram is the magnitude of the cross product. So you take this squared plus that squared plus 1 squared. Okay, and that's how you get this piece right here. This is the area. So essentially this part right here, well, times the dA, is the area of the parallelogram, of this small little parallelogram. Okay, so that's where the formula comes in. I will point out one thing you got to be careful about. Remember, there's a 1 right here. Just keep in mind there's a 1 right there. So when you work problems, because that's easy to forget, because it's like it's hard to see. But remember that there's a 1 right there. Okay, so let's go ahead and do some exercises. So let's go number 1. This is on 15.5a. Find the area of the surface that lies above the triangle with vertices 0, 0, 2, 0, and 2, 4. So this triangle right here. Okay. So so it's important to be able to draw what this looks like in the XY plane. And it goes through 0, 0, 2, 0, and 2, 4. So if that's a 4, it's 2. Okay. So we know this bottom part is y equals 0. What's the equation of this? What's the equation of this line? This upper part.
Oh, wait.
That's 2, 4, and this is 2 right here.
It's 2x.
Yes, it's going to be 2x. Okay, so that'll be helpful later on when we set the integral up, because we can integrate in y first and go from 0 to 2x, and then we can integrate in x and go from 0 to 2, right? Okay, so over here, meanwhile, we need to take this and solve it for z, because remember, what we're shooting for is this right here, z equals f of xy. Okay, so this right here is the equation of the surface, but in order to apply it, it's best to solve for z. So you have 4z is x squared minus 2y plus 5. And then, so z is equal to x squared over 4 minus y over 2 plus 5 over 4. Okay. And that's going to be our f of xy. Okay. So let's go ahead and so for the formula, we need to calculate the partial with respect to x and the partial with respect to y. Okay, so what's the partial with respect to x?
It would be, oh shoot, partial derivative, yeah?
Yep.
Okay, in respect to x, it would be x over 2.
Yep, that sounds good to me. And with respect to y, it's just going to be
1/2.
yeah, negative 1/2. Okay, so that means, okay, so if you have the surface area, wait a minute, is that the notation? I can't believe it. Oh. Oh, A of S, oops. Dang, I can't erase that now. Okay, so it is, we're going to set up the integral, and here we know that we can go y first and have it go from 0 to 2x, and then we can go x from 0 to 2. Okay? Because if this is a vertical piece right here, it goes from 0 to 2x, if that's x. And then you just add up all the x's from 0 to 2. Okay, so that's how that works. Okay, and then it's going to be the square root of, I'm going to square that one. So that's x over 2 squared, and then we square that one plus that one squared, plus 1. Okay, hold on. Now there's one thing that I noticed, that we're taking the integral with respect to y first, okay, and there's no y's in here. So what does that mean that we can do?
Just take the normal derivative? I don't know. For the
Okay,
integral,
so when you take the integral here, you're just going to get a y, right? And then that y is going to be evaluated from y equals 0 to y equals 2x, right? So instead of going through all those steps, what you can do is just take 2x minus 0 and just stick that right there.
what?
Yeah, if there's no y, if there's no y's there at all. Because that's what's going to happen anyways. If you take if you take an antiderivative, it's going to be y, right? And then you value from 0 to 2x. So 2x minus 0, which is just 2x. And then this part right here, that's what, x squared over 4. I'm not happy with that too. Okay, x squared over 4 plus 1/4 plus 1, so that's going to be plus 5/4, all to the 1/2 dx. I can take the 2 in, and that'll knock all those 4s out. So I'll do that as I feel like it. So you get there, and then now we take an antiderivative of this. So now we got antiderivative, and fortunately, the derivative of the inside part is 2x, and we have an x right there. So that means this is x squared plus 5 to the 3/2. And if we put a 1/3 out here, I think we got it. Because you're gonna have you're gonna have 3/2 coming down here. So the 3 will take care of that, and then you'll have a 2x coming out, and the 2 from the 2x will take care of this 1/2 from here. So plug a 2 in first. That's going to be 4 plus 5. That's 9 to the 3/2. Minus, and then you plug a 0 in, and you get 5 to the 3/2. And that works out to being 9 minus 5√5 over 3. Okay, so that's the answer right there. 9 minus 5√5 over 3. Any questions about that? Okay, let's move on to the next question. Find the find the area of the part of the surface that lies within the cylinder x squared plus y squared equals 16. Okay, so here we have, what's this the graph of?
Isn't it a circle?
Yes, it's a circle.
4 or 6?
Yes, the radius is 4. So the radius is 4. That means we come out to 4 in all these directions, and something like that. Oh, goodness. Okay, so something like that. It's kind of hard to draw with this writing tablet. Okay, so that's what we got right there, and so that means that you should, when you see something like this, you should immediately think, hey, let's maybe try polar coordinates. Things might work out better if we do that, right? And so this becomes r equals 4. And this is the area that we're going to be, going over, to the area of the surface. So if we can integrate across this right here by having r go from 0 to 4 and theta go from 0 to 2 pi. Okay, r dr d theta. Of course, we need the other part, which is the square root of the fx squared plus fy squared plus 1, right? I just put the 1 right there already. Okay, so anyways, this is our f of xy. And so what do you feel like doing with this?
Are
Anybody
we
feel
still
like
gonna use the partial fraction?
Yeah, let's take the partial derivative. That sounds like lots of fun. Okay, what's the partial with respect to x of this?
And y?
Yes, it's just y, and with respect to y, it's just going to be x. Okay. Yes. So, should we put y squared and x squared here? Or,
We can
what's
put
y? What's that?
like cosine squared and plus sine squared, so that's gonna be 1. Oh, sine.
Yeah, this can be that. Okay, so this is our sine theta, and this is our cosine theta. So you put those in, square them. Now you're going to have sine squared plus cosine squared, but r squared times that. So all this is going to become r squared, right? That's a 4. Okay, great. So we got this integral here, and we can go ahead and take the integral. Okay, now one thing you notice that there's no thetas anywhere. That means we can just take that minus that. Okay, so this is going to be r squared plus 1 to the 3 halves. Hey, this is just like the last one. That's weird. R equals 0 to r equals 4. So that's going to be 2 pi times 1/3. I guess I could have put that. I could have put that right there. Well. Okay, so if you put a 4 in here, you get 6 to 17. And if you put a 0, you get 1. So that's just that. So I'm getting 2 pi over 3 times 17 root 17 minus 1.